Um, Hello, thanks for joining us this evening. You were brought into the session with your microphone and video off. If you have questions, please put them in the chat. Megan will collect them and address them to Bob after his presentation. The program will be recorded and will be made available on the Detroit Public Library YouTube channel and through Wayne State University's website. I am Jennifer Dye, a librarian at Detroit Public Library. We've had astronomy programs for several years. Before the world turned upside down, we had in-person programs. When things fell apart in spring 2020, we put programs on a hiatus, and then we launched these online programs, which I think are working very well. We've been fortunate to work with Megan McCullen, director of the Wayne State University Planetarium. In addition to her able work on the Zoom programs, she has provided a link into the community of Wayne State University faculty and alumni. Megan, would you like to talk briefly about the program and maybe what you have coming up?
Sure. Thank you, Jennifer. We're always glad to participate in this, and I appreciate all of your organizing of us as well. You're the one who keeps this running. I feel like mostly I just show up and monitor the chat, but I am glad to do it. We just came back to campus for the fall here at Wayne State in Detroit, and we are back to doing lots of in-person programming. So starting next weekend, so not this weekend because it's Labor Day, but starting the following Friday, we'll be doing our free Friday night planetarium shows, which can be found on Eventbrite if you want to reserve a seat for it. We do them at 6 and 7:30 almost every Friday. So you can check there to make sure we'll be running them. There's a few weekends we do not do them because there are other events happening. September 22nd and 23rd is a great event called Astronomy at the Beach. I suspect Bob will be there. And that is a great chance to, I'll put a link in the chat. It's a great chance to get out with dozens and dozens of telescopes, dozens and dozens of experts to show you the night sky through their telescopes. It's a wonderful event. There's lots of educational programming as well, but it's a lot of fun and a great chance to see what's up there. I believe we are also going to be out on Belle Isle tentatively on October 14th. There's a partial eclipse that day, so we're going to be out during the day with our solar telescopes. And then in the evening, we'll be out with our evening telescopes so that we can also look at the sky. But stay tuned for that, but that's a tentative. And we are bringing back our in-person lectures this fall at the planetarium. So we have a Science Under the Dome lecture series that is a general science lecture series. And our first lecture will be on September 28th at 6 p.m. I'll put a link again in the chat, where one of our newer astrophysics faculty, Dr. Renee Ludlam, will be talking about neutron stars and her work on neutron stars. And then in October, we're going to have a biologist whose title is to be determined. And November is to be determined. And December, we're having the conservation scientist from the Detroit Institute of Arts come in to talk about mummy portraits and chemistry in art museums. So those are all free and open to the public. Roger, I think you're too far away for those, unfortunately. But for anyone who's local, you are very welcome. And lastly, at Wayne State this fall, the theater department is going to be putting on the play Silent Sky, which is about Henrietta Swan Leavitt, one of the early female astronomers. So I will put a link to that in as well. We're really excited to collaborate with them, maybe on some programming around that performance as well. So we've got lots happening at Wayne State. We're excited to be back here.
That sounds really cool. I need a link for that to put in the WAS newsletter.
Oh, sure okay. Yes. I'm going to put it in the chat, Bob, and then you can grab it later. And that's it. That's a lot. So
it is
I'm
a lot.
Just excited.
Great. I'm hoping that several branches of the Detroit Public Library will have programs for the October eclipse, and we're looking ahead to April as well. Our speaker, Bob Trembley. He's a volunteer NASA JPL Solar System Ambassador. He's the president currently of the Warren Astronomical Society. Or are you? I've lost track.
Yes, no, I am.
I thought you were. And a Factotum, for the Vatican Observatory Foundation.
That's a great word.
It is a great word. And he's going to speak to us tonight about exoplanets and why they're not just science fiction anymore.
All right, let me share my screen here. And there we go. All right, you out of my face. Over here. All right. So, as stated, I am Bob Trembley. I am a volunteer NASA JPL Solar System Ambassador. This is a program where NASA finds people that do a lot of outreach and they recruit you. And they have one of the most arduous applications I've ever seen. And once you get approved, you get freebies from them, and you have to give like 4 presentations or do something during the year. But essentially, it's being a volunteer NASA cheerleader, and that's just fine with me. So I am the president this year of the Warren Astronomical Society. I'll probably be running again for next year's. The Warren Astronomical Society has a meetup. We meet twice a month, first Monday and third Thursday at Cranbrook Institute of Science and Macomb Community College. We also meet online. I am a member of the Great Lakes Association of Astronomy Clubs, and through no fault of my own, I got put on the board of that, and I do some updates on their website. But this is a whole bunch of astronomy organizations in southeastern Michigan that have gotten together, and one of the major events they do is, I think was mentioned, Astronomy at the Beach, which is going to be September 22nd and 23rd. There's a link at the bottom there. This is Michigan's largest free astronomy event, and talk about dozens of scopes on the field and presentations. It is a fantastic event. I am also a factotum for the Vatican Observatory Foundation. Factotum is just somebody who does everything, jack of all trades. But so the Vatican Observatory, yes, they have a telescope. Actually, they have several. And this is my boss, Brother Guy Consolmagno. He has been coined the Pope's astronomer, and if I can drop a name like that, why wouldn't I during my lecture? There's actually a video on YouTube called The Pope's Astronomer, so you should go see that because it talks about him. It's just fantastic. One of the many things I do for them is I podcast. I'm a podcast host, and I also edit them. So that's really cool. We have interviewed some fantastic lecturers. So before I get to talking about exoplanets, let me introduce you to my mother-in-law. This is Judith Martin. She is a let's see, get that font in there bigger. She is a voracious consumer of astronomy programs and things like that. I asked her, Mom, you know what a pulsar is? She's like, I think I've heard that. And I'm like, okay, fine. We need a review. So our sun lives in a vast sea of stars, and I'll be showing that to you too because that's really cool. So in that sea are vast clouds of gas and dust that spread throughout the galaxy, and they condense due to gravity, solar wind, and pressure, and supernova shockwaves, other things. And these are called star-forming regions, and stars form out of them, like our sun. Our sun and its planets condensed out of these clouds, and our sun is currently about halfway through its 10 billion year lifespan. I love this picture. This is from National Geographic when I was a kid. So near the end of the sun's life, it's going to turn into a red giant, and then it's going to turn into a white dwarf. Now, why am I talking about white dwarfs? Because they found exoplanets around them. So a white dwarf has a mass comparable to the sun packed into a sphere about the size of the Earth. They are no longer undergoing fusion. They're very dense and hot. And the little guy on the right is the smallest known white dwarf. It's incredibly dense, almost to the point of turning into a neutron star, and likely the result of a collision of 2 white dwarfs. Okay, our sun is a Class G star, and that would be that guy right there. Class K and M stars are considered red dwarfs, and they are so dim they're invisible to the naked eye. And the first one was discovered in 1753. Cool thing about them is they are by far the most populous star in the sky. So we didn't know about the most populous star in the sky until the mid 1700s. Okay, there are a lot of stars larger than our sun, but the percentages are low. And this image shows the relative sizes of main sequence stars. The really big ones, the type O's there, they burn through their fuel in about 10 million years. And those stars can go boom and in a supernova explosion, and those can collapse into black holes, which we're not going to talk about because that's a whole lecture on its own, and neutron stars, which is also a lecture all on its own, but we're going to talk about them. This is the collapsed core of a supergiant star, 10 to 25 solar masses and only 6 miles across. Really, really tiny. A pulsar is a type of neutron star that has these jets coming out of them, and as it rotates, if those jets face you, like a lighthouse, you will pick that up via radio. The pulsar at the center of the Crab Nebula was discovered by astronomers in '68, is among the first pulsars discovered and the fastest. It has a rotational speed of about 33 milliseconds. The time-lapse movie on the right there is created from 10 Hubble exposures, and it shows wave-like rings coming out from that pulsar. So that's really cool. And this is from Space Engine. Now, Space Engine is an application, a Windows app that allows you to go anywhere in the universe. And I am ridiculously dangerously close to this pulsar right now. And you don't want to be this close. You really don't want to be in line of those jets either. So I'm pretty sure most of you have seen a spectrum of the sun, either split through a prism or a crystal at some point in your life. Well, if you spread that way out, you see these black lines. And keeping up explanations short, these are fingerprints of elements that are in the sun. In short, looking at the light from a star, you can tell what that star is made out of, and that's just mind-blowing and very useful. So gravitational lensing is when the gravity of a massive object or object like like several galaxies bends the light from a more distant object. You saw that in the previous lines of the pulsar and the neutron star kind of bending the light. But this image is from the Webb's first deep field, and you can see the smeared orange galaxy. What's happening is the gravity of that galaxy cluster is bending and duplicating that light. And that too is mind-blowing. So what is a planet? Well, okay, we're going to talk about planets during exoplanets. We got to talk about what's a planet. Well, the definition has changed over time. In ancient times, it was something that was bright and moved across the sky. And this video here by CGP Grey on YouTube is just fantastic. Go back here, Pluto planet. I'll let you see that for a second. Fantastic video, very informative. So, and even the number of planets that we've known about has changed over time, and planets have been discovered and reclassified, which pissed a lot of people off. But the International Astronomical Unit defines a planet that is it's something that's in orbit of the sun. It's round due to hydrostatic equilibrium, and it's cleared its neighborhood. That is some kind of bit of a contention to some people because there are no Earth-sized planets in Earth's orbit, but there sure are a lot of asteroids. So enough with the review. So this guy, Albertus Magnus, also known as Saint Albert the Great. Now, this guy was one of those guys that just did everything. Philosopher, scientist, bishop, later canonized as a saint. Holy mackerel. But he asked the question, do many worlds exist, or is just a single world? And this concept is called cosmic pluralism. It describes the belief that there are numerous worlds out there in addition to Earth. So it's been around since ancient times and more recently entering into the mainstream. And I'm pretty sure that these guys helped keep it in the mainstream too. You know, I actually had to look to see what was the first TV series or movies that mentioned planets. Well, 1934, Flash Gordon, Earth was threatened by a rogue planet, so not from the solar system, and Superman came from the asteroid debris field formerly known as the planet Krypton. And there have been any number of popular science fiction and fantasy movies that take place on other worlds. It's just part of the culture. But the first real planet, exoplanet, around a star wasn't discovered until 1992. The radio astronomers discovered these guys around a pulsar. And this one was in '94. They found a third planet named Draugr, And this is from Space Engine. This is a visualization from the surface of that planet looking at the pulsar. So Draugrs are also a creepy undead monster from the game Valheim, which I've been playing a lot. But in 95, there's a lot of debate over which exoplanet discovery considered the first. But in 95, scientists discovered 51 Pegasi b, and it forever changed the way we see the universe and our place in it. This guy is in orbit around a main sequence star like our sun, so it wins. It's about half the size of Jupiter. It orbits the star much closer than Mercury orbits our sun. So here you see our 51 Pegasi is pretty much like our sun. They're very similar. So there's the orbit of Mercury out here, and you see this guy is much closer. It is considered a hot Jupiter. Its atmosphere is likely being blown off in a long comet-like tail as it orbits its star. So before we discovered this exoplanet, this is how we thought all planets, planetary systems would look like. You get the rocky terrestrial planets on the inside and the gaseous ones further out, and then I like how Wikipedia and other sources say things like ushered in a new class of planets called hot Jupiter or marked a turning point. My take on it, the way I remember it, was it took our current hypotheses of planetary system formation and crumpled them up and threw them away, or threw a monkey wrench into the works. So it is a hot Jupiter, and planet was unofficially dubbed Bellerophon by astronomer Geoffrey Marcy, following the convention of naming planets after Greek and Roman mythological figures. Bellerophon is the figure from Greek mythology who rode the winged horse Pegasus. Bellerophon is also the name of the starship from the fantastic science fiction movie Forbidden Planet from 1956 by MGM, starring Walter Pidgeon, Anne Francis, and Leslie Nelson. If you haven't seen it, you should. It's fantastic. So the IAU, the International Astronomical Union, ran a public naming contest for this exoplanet. In December of 2015, they announced the winning name was Dimidium, Latin for half, referring to the planet's mass of approximately half that of Jupiter. 2017, they discovered traces of water in the planet's atmosphere. And in 2019, its discoverers won the Nobel Prize. Is this a surprise to anybody? No. So where are they? So now we have an actual planet orbiting a main sequence star. We need to define that a bit more for the textbooks. So the IAU says an exoplanet is an object with a mass below 13 Jupiter masses. Why? Well, if you go 13, then it starts fusing, and that's not a planet anymore. These images I created using Universe Sandbox, and I created a 12.9 Jupiter mass exoplanet here. And when I made it 13, it started fusing, so that was pretty interesting. So they have to be round. The other requirements are pretty much the same as planets. They have to be round, and they have to have cleared their neighborhood. Okay, so that makes sense. This is the actual IAU definition, but when you start talking about L4, L5 instabilities and the square root of 621 somehow figuring into the equation, my eyes kind of glass over. So in short, it's a body outside the solar system, orbiting another star, and it's short for extrasolar planet. The first time it came into use was 1992, the first time you're going to find it. Interestingly enough, my wife, who is now a retired middle school teacher, her science book from 2005 had no mention of the word exoplanet. The replacement to that book does have a chapter about exoplanet, and Dale Parton, the first vice president of the Warren Astronomical Society, told me that he teaches astronomy. He told me he just got a new textbook, and it too has a chapter on exoplanets. So I think I'd like to see that, what they're teaching people. So they can be orbiting a single star like our sun, or multiple stars. They can be unbound to any star, called a free floating or a rogue planet. The picture here is an example from the European, the ESO, European Southern Observatory, showing an artist impression of a rogue planet. Over on the left, it's glowing red in visible light. On the right, it's glowing very brightly in IR. So that is how you discover them. Now, when I went to one of these free-floating rogue planets in Space Engine, I can't find a single one that isn't black as pitch. I even went to a star cluster with stars everywhere and found one, and it's just, you can't see anything. It's just black. And the funny thing is that NASA has all these this exoplanet travel bureau with all these posters, and they have one for this thing, and it's here, the planet with no star, and there's a lot of those. So there's several thousand of them, as a matter of fact, and this is an image from the interactive NASA Eyes on Exoplanets apps, which I'll be showing at the end here. You can click on any one of these stars, and it'll bring up an info panel on the planet, the star, the system. You can compare it with solar. It's a fantastic app, great for schools. So the current one, as of today, and I took the top screenshot here today. It increases weekly, and if it's not increasing daily, it will be soon. So the current count is 5502. So this chart shows exoplanet discovery since 92, and you can see it's jumping significantly around 2016. Now, these are color-coded. These are the different discovery methods. And as you can see, the transit method in green here is by far the most numerous discoveries, followed by the radial velocity, which is how they discovered the first one. And you can see it's just been steadily growing since. But transits has just shot through the roof. So what is that? That's if a planet crosses or transits in front of the disk of the parent star, the observed brightness from the star drops a small amount, and the amount by which it dims, and on the size of the planet, they can tell how big the planet is by doing this. This is just crazy, and the fact that they can see the star's light dip just a little bit, that just blows me away. So transits require the planet's orbit to be angled such that, from our line of view, we can see it going in front of the stars. So only a small percentage of planets happen to be in this orientation. So there's a lot of them out there that we'll never find by the transit method. The Kepler Space Telescope used this transit method to find a whole bunch of exoplanets, and I'll be talking about this in more detail a bit later. Transit timing variation. When you have multiple planets present, they can tug on each other. And small variations in the timing of a transit from one transit to another can indicate the presence of another planet, which may or may itself not transit. An example of this is Kepler 19 B, C, and D. Kepler transits from Kepler 19b suggested the existence of 19c, which was later found using radial velocity. So that's kind of cool. So when a planet orbits multiple stars, or if the planet has moons, its transit time can vary significantly per transit. You can get this weird jumble at the end there. And although no new planets or moons have been discovered using this method, it's successfully confirmed many transiting circumbinary planets. So that's pretty cool. This is kind of confusing. Okay, if a transiting planet is on an eccentric orbit, like very eccentric and angled like this, the duration of the transit is sensitive to the orientation of the orbital ellipse and the line of sight back to us. If the orbit of the planet is close enough to the star, general relativity can start causing the periastron, the orbit precesses around the star, so it may not be transiting after a while. So that's kind of crazy. Radial velocity, as I said, this is the method that has discovered the most stars. As a planet orbits the star also moves in a small orbit around the system's center of mass. It's called a barycenter. Variations in the star's radial velocity, that's the speed which it moves forward and away from Earth, can be detected up to 1 meter per second, light years away. Again, that just blows me away. What happens is that radial velocity, it can cause shifts in the spectral lines that you see from that star due to the Doppler effect. Gravitational lensing, I've talked about that. Microlensing is, every star, even our sun, can bend light from something behind it. So microlensing occurs when a gravitational field of a star acts like a lens, magnifying the light from a background star. Planets orbiting a lensing star can cause detectable anomalies in that magnification over time. So this is most sensitive to detecting planets around 1 to 10 AU, so planets that are close into their stars. Direct imaging. Planets are extremely faint compared to the planet stars. A sun-like star is about 1 billion times brighter than reflected light from an exoplanet, making it difficult to detect. Parent star also causes glare, which washes out planets. So what you got to do, it's necessary to block the light from that parent star in order to reduce the glare and leaving the light from the planet detectable. Doing so is a major technological challenge and requires extreme optothermal stability. Yeah, great. All exoplanets that have been directly imaged are both larger than Jupiter, and widely separated from their star. This one was taken in, I don't have it down. This was several years, as you can see down here. So this image was taken using the Keck Observatory in Hawaii. Keck uses laser guide star adaptive optics. These lasers, this is crazy, excite sodium atoms in the Earth's mesosphere, creating an artificial star that can be used to measure atmospheric turbulence, and then you can use computer software to edit that out. Here's an example of how effective that is. So you can see why this might be helpful looking for exoplanets. This one was pretty interesting. I've heard, a long time ago, like 2004, they said they found something about Fomalhaut, and it was originally thought to be an exoplanet. And now we found out it's an expanding cloud of gas. Oh well, we lost one. So that image was taken with the Hubble Space Telescope, which again I'll be talking about in the future. One of the more recent direct imaging pictures, like August 24th, this was posted. This guy has found planets that are creating spiral arms around its star. And that was taken with the Large Binocular Telescope in Arizona. Some other scopes doing exoplanet research are Gemini North and South. It has the Gemini Planet Imager, a high contrast imaging instrument that allows for direct imaging and integral field spectroscopy of extrasolar planets and nearby stars, and it has its own cool logo. So the Very Large Telescope is 4 8.2 meter and 4 movable 1.8 meter auxiliary telescopes that can work together as a giant interferometer. This thing has the VLT has the Spectropolarimetric High Contrast Exoplanet Research Instrument. It's that thing circled in red there. Again, it allows imaging as well as spectroscopic and polarimetric characterization of exoplanets. I'd never heard the word polarimetric, so let me read this to you. This is hilarious. Oh wait, where is it? Polarimetry is the measurement, thank you, an interpretation of the polarization of transverse waves, most notably electromagnetic waves such as radio or light waves. Typically, polarimetry is done on electromagnetic waves that have traveled through or have been reflected, refracted, or diffracted by some material in order to characterize that object. Oof. Yikes. Someone Star Trek technobabble foo is strong. So the Subaru telescope, right next door to the Keck, it has the Subaru Coronagraphic Extreme Adaptive Optics. They're using it too to do pretty much the same thing. So this was released very recently, August 9th. This is a 17-year time lapse of a Jupiter-sized exoplanet orbiting a star 63 light years away. And this is the NASA Eyes on Exoplanets visualization of that planet. So how many exoplanets could there be? Interesting question. Here's a post from one of the astronomers I follow. And this is pretty much backed up by the NASA site, but current statistical estimate is that there is one planet per star in our Milky Way. And our Milky Way has 100 to 400 billion stars. And if that sounds like a lot, the number of rogue planets discovered so far is 30, half of those being candidates. The estimated number of rogue planets is nearly 2 Jupiter mass rogue planets per star in the Milky Way. And another study suggests up to 100,000 times more rogue planets. So they're everywhere. That's a lot of exoplanets. And I'm pretty sure Carl Sagan would love what's been going on with exoplanet research today. So another surprising study came out just recently suggesting that different regions of the Milky Way may spawn different percentages of planets. So hold that thought. It may be a little more, a little less than one, but if you got 100,000 times the rogue planets, you got a lot of them. Now, that's just in our Milky Way. Our closest neighbor, Andromeda, has 1 trillion stars. And even if 1% of the stars in Andromeda had planets, that'd be 10 billion planets. So, yikes. So, I mentioned about the first exoplanets, the one around the neutron star and the gas giant being discovered. There's an interesting story here. In 1914, sometime between 1914 and 1917, Adrian van Manen found what he called a very faint star. And he spotted it due to its proper motion, meaning it's moving relative to other stars. He wasn't sure how far away it was at the time. It was later named von Manen's star. 1917, the spectrum was taken on glass photographic plates from Mount Wilson Observatory by this fellow, Walter Sidney Adams, who would later become the director of Mount Wilson. They assigned it a class of F0 because of what they saw in the spectrum. There was evidence of calcium and other heavy element absorption features, somewhat higher than the sun. And there's some conflict between articles. I found several different articles that said Adams did it or Van Manen did the classification. So I'm not sure. So I just said both of them did it, whatever. So in 1923, Wilhelm Luiten, I'm sorry, I'm messing these names up. He published a catalog with stars with large proper motions, and Van Manen's star is labeled as one of 3 known white dwarfs, a term he coined. So let's skip ahead to 2012. Ben Zuckerman, as astronomer, was preparing for a talk, and he stumbled across these glass plates made by Van Manen in 1917. And he was doing a lecture on polluted white dwarfs. Yeah, polluted what now? Okay, back to white dwarfs. Recall these guys, dense remnants of stars. Polluted white dwarfs they have heavy elements such as magnesium, iron, and calcium, which these guys detected in their normally clean atmospheres, and they show up in its spectrum. And these elements must have come from bodies like asteroids or planet, which got torn apart by the white dwarf's gravity and burned up. So asteroids and planets don't randomly just change their orbits. They need something to push or pull them. And the best candidates for that are planets themselves, or rather exoplanets. So looking at it with a perspective of 21st century, he's like, oh my God, these guys found evidence for an exoplanet in 1917, but didn't know what they were looking at. So they don't win the Nobel Prize. So today we know that Van Manen star is about 14 light years away in the constellation Pisces, and it is the closest white dwarf to the Earth that is not part of a binary system, and it eats planets and asteroids. So in 2020, they found a planet in M51, the Whirlpool galaxy. In September 2020, a detection candidate orbiting a high-mass X-ray binary in the Whirlpool galaxy. The planet was detected by eclipses of the X-ray source. So they quite possibly have found an exoplanet in another galaxy. Yikes. So there are a lot of interesting and weird exoplanets. This screen here is the featured exoplanet menu from NASA's Eyes on Exoplanets app, which is a web-based app. You can run it on your phone, your tablet, your PC, your Mac, whatever. You can click on any one of these guys and go to it, and it'll bring up an information screen on the planet showing a representation of the planet compared to Earth, its star compared to our sun, and give you some information on the planet. So some of the weird guys, I like this. It says WASP 12B is doomed. Well, it probably is. This is from NASA's app. This is from Space Engine, that app I play with a lot. As you can see, it is egg-shaped, and its atmosphere is being blown off to the left by its star, which is probably what exactly is going on. And here's KOI 55b. I love the folks that wrote the description for this one. Kepler 70b, aka KOI 55, could well be another circle of hell with an average temperature hotter than the sun's surface. It used to be a Jupiter-sized planet until it spent some time inside its now dead star, a trip that destroys most planets. But this one left a Freddy Krueger-like burned world smaller than Earth, about 12,000 degrees Fahrenheit. It is one of the hottest planets discovered, and it is evaporating itself, soon to be another victim. Yikes. So there are a lot of these really hot planets. This is the same planet in Space Engine, so you can see they're represented a little bit differently, but it's hot. So there are a lot of exoplanets, right? 5,500 so far. I found this mosaic from Halcyon Maps, which I'll put a link in here, the next screen. This is amazing. There it is, halcyonmaps.com. That thing, he split these into like a dozen different pieces, but he put, again, the mosaic. He's got every exoplanet discovered, from the small ones to the hot ones. That's just amazing. I want to get that and put that on my wall. So many exoplanets likely have rings similar to those in our solar system. However, only one set of exo rings has been found so far. The exoplanet is called J1407b. Love those names. It's a gas giant that has 30 rings, each with a diameter of tens of millions of kilometers. The rings are probably made of dust because it is too hot to support ice being close to its star. So what's the closest exoplanet to Earth? That would be Proxima Centauri b. 4 light years away. Its mass is consistent with being slightly larger than Earth. Based on what we know about exoplanets, it's most likely a rocky planet. It also orbits in the habitable zone of its star, which means it could have liquid water on its surface if it had an atmosphere to support it. Calculations suggest that Proxima Centauri b is tidally locked, so one side faces its star at all times. It would make for some interesting atmospheric and weather conditions. Like the dark side of the planet is going to be frozen, and the front side, who knows what the weather is going to be like right at that junction. Man, this is just some eye candy from the planet from Space Engine. I thought that was a cool shot. So Proxima Centauri is a red dwarf. Here it is compared to our sun. It gives off about 600 times less light than our sun. It's the closest star to Earth after our sun, but it's still 9,000 times further away than Neptune. Now, red dwarfs can blast out massive flares, much stronger than we've seen in our sun. And in 2019, Proxima Centauri did just that. It let off a mega flare, only shown for 7 seconds, but it was mainly visible in the ultraviolet. It was 100 times more powerful than flares of our sun. Now, what do you think that's going to do to the surface of those planets? Well, have your SPF 1 million ready, because that's going to be pretty bad. So Proxima Centauri system, again, this is from Space Engine. It's a very weird system. It's got 2 inner planets on wildly different orbits and another planet much, much further out. So that is the closest star to us, and it has exoplanets. So can you travel to exoplanets? Real simple. No. Using our current tech, we can barely get past the moon. So nope. In the case of Proxima Centauri, why would you want to go there? I mean, we've made it to the closest exoplanet. Slash. Oops. So I could expand this one screen and one slide into an entire lecture, and I've done that about traveling to other stars and stuff like that. But again, this is a topic for an entire lecture. So a lot of space telescopes are doing exoplanet research. You might be familiar with this one. Launched in 1990, the Hubble Space Telescope is a large space-based observatory that revolutionized astronomy after the installation of corrective optics during the first servicing mission. It's named after Edwin Hubble, who figured out that nebulae were actually galaxies and figured out galactic distance scales and came up with the idea that the universe is expanding, now known as Hubble's law. Hubble Space Telescope has one of these fancy exoplanet travel bureau posters. There's a lot of those. Hubble has observed planets inside and outside our solar system and the most distant stars and galaxies yet seen. In 2000, Hubble studied the first exoplanet known to transit, and it was also the first telescope to directly detect an exoplanet's atmosphere. In 2018, it studied TRAPPIST-1 planetary systems. 30 years after launch, it continues to investigate atmospheres of transiting exoplanets, remains one of our most valuable and successful windows on the cosmos. It celebrated its 30th year in 2020, and it's operating on its backup computer. So it's well past its factory warranty, and it's losing altitude every year, and we'll need to either robotically deorbit it fairly soon or have its orbit boosted, which is a possibility. NASA and SpaceX are looking into a study of sending a commercial crew to boost the Hubble, and I don't know if the mission would include replacing some hardware, but there's some parts that do need replacing. You may recognize this image from the Hubble. This is one of the more famous images and the favorite of my mother-in-law, who's the astronomy nut. So the Spitzer Space Telescope launched in 2003 on a mission to become NASA's premier infrared observatory. It discovered a ring of Saturn, studied the farthest galaxies, and identified two of the most distant supermassive black holes ever discovered during its 16-year mission. It is named after astrophysicist Lyman Spitzer, who conceived the idea of putting telescopes in space. Seems fitting. The study of exoplanets was not one of Spitzer's original goals, but when innovations during its mission improved its precision, it turned it into a critical tool for exoplanet work. It was the first telescope to directly detect light from exoplanets. It displayed a key scientific role in everything from planets larger than Jupiter to small rocky worlds similar to Earth. In 2017, Spitzer revealed the TRAPPIST-1 system. This is a pretty famous picture. First known system of 7 Earth-sized exoplanets. Most of them probably all tidally locked to their moon or their sun. Data from Spitzer also showed that all these planets are likely rocky. The TRAPPIST-1 system here it is from NASA Eyes on the Exoplanet, and the green area would be the habitable zone around that star where you could be at liquid water on the surface. Here is the travel poster for the Spitzer, which depicts the TRAPPIST-1 planets and its star in the background. And there is the TRAPPIST-1 system from the Travel Bureau, and they also have a coloring book page, so you can have your kids do color. They've got a lot of these coloring book pages from these travel posters. These are really, really cool. So in 2009, the Kepler Space Telescope was launched, designed to survey a portion of the Earth's region of the Milky Way, discover Earth-sized exoplanets in or near the habitable zone, and estimate how many of the billions of stars have such planets. It is named after Johannes Kepler, a German, another one of these guys that just did everything: astronomer, mathematician, astrologer, natural philosopher, and writer of music. Yikes, guys put me to shame. He also provided one of the foundations of Newton's theory of gravitation. So this is what the Kepler was looking at. This is the area of the sky. Kepler mission looked continuously at this area of the sky, at 100,000 stars in that region. Its field of view is extremely large for an astronomical telescope. Most telescopes like the Hubble have only a small region at the time, about the size of a grain of sand, held at arm's length. This one was much larger. And since transits only last a fraction of a day, the stars have to be monitored continuously. And so that's what they did with the Kepler Space Telescope. Now, many spacecraft use these things called reaction wheels to maintain proper orientation. They're like gyroscopes. They electrically you can move the spacecraft and aim it by telling the gyroscope to move differently, and you put 3 on different axes. They're just really cool, except when they fail. Kepler had 4 of these, and after just 4 years, 2 of the 4 had failed, and 1 of the 4 was there for redundancy. So we're looking at the Kepler being a piece of space junk. Well, they came up with an ingenious fix for this. Mission planners were able to compensate for the lack of the reaction wheel by balancing Kepler against the pressure of the solar wind. That's crazy. But it needed to occasionally burn fuel, and instead of continuing the one spot, as it orbited the Earth, it stayed on one spot for a while and then moved to another spot. So it actually looked at several different spots of the sky. But in 2018, it ran out of fuel after 9 years, and it was retired. Here is the final image from Kepler showing a galaxy, showing a bunch of galaxies. There's Kepler by the numbers. Lots of data, and lots just an amazing mission. So Kepler 186F is the first Earth-sized planet discovered in a potentially habitable zone around a star, so it got its own poster. Star is much cooler and redder than our sun. If plant life does exist, photosynthesis could have been influenced by the star's red wavelength, making the color palette very different from the greens of the Earth. So there are some more. There's just tons. Kepler is very popular. There is a double star system like Luke Skywalker's Tatooine. Kepler 16b orbits a pair of stars, so they found a Tatooine clone. And this is pretty interesting. A team of transatlantic scientists using reanalyzed data from the Kepler Space Telescope have discovered an Earth-sized exoplanet orbiting in the habitable zone. Scientists discovered this planet when looking through old observations, and that's just amazing. So they're not the only one doing it. This high school student developed a mathematical model and calculated there could be as many as 560 of these hidden planets and identified 96 areas of the sky where they can be found. A high school student. Yikes. That's crazy. So TESS is the Transiting Exoplanet Survey Satellite, launched in 2018, and its whole job is to survey almost all of the night sky looking for these transits. It identifies them by the tiny dips in the star's brightness, but unlike Kepler, which focused on a single patch, it is conducting an expansive survey of the entire sky. Its two-year primary mission is already done, and it monitored more than 200,000 pre-selected stars and detected over 1,900 candidates. I believe that number is actually increased now. It's continuing to operate, and by the numbers, those are probably all inaccurate now because that's what in April, so the numbers are still going up. And the James Webb Space Telescope, which launched and was a nail-biting deployment earlier in 2022. This image is from NASA's web-based Eyes on the Solar System app, which lets you go and see every spacecraft that NASA has ever put up, which is amazing. And I thought when I saw this picture, I thought, like, pink, what the heck's going on? I thought there was something wrong with my browser or my graphics card. I reinstalled graphics drivers. I could not figure out what's going on until I looked it up, and nope, yep, it's pink. That's because of the coating on the sun shield. So you don't see that pink color in a lot of the James Webb Space Telescope things, but yeah, it's pink. So this is named after James Webb, who served as the administrator of NASA for quite some time. And he also dealt with the Apollo 11 fire, which must not have been fun. So travel poster. Here's the web travel poster. The web is just amazing. It's been doing amazing things, and some of the things it's doing with exoplanets is returning spectra of them. This is the remember that WASP. This is the spectra of WASP 96b. I believe that's that weird egg-shaped guy. So they're taking spectra and thermal emission spectra. I believe they found water. They're looking for oxygen. So this is a recent picture. This is the Ring Nebula by the James Webb Space Telescope, and you can zoom that way in, and it's on all three of my monitors right now because it's gorgeous. Project Eden. You probably haven't heard of this. Its goal is to discover and explore habitable exoplanets within 50 light years of Earth. I did a search on the NASA exoplanet site. There are 184 known exoplanets orbiting 104 stars within 50 light years of Earth. Okay, most exoplanets have been discovered at ranges between 100 and thousands of light years, and you cannot characterize those in any detail. Project Eden wants to characterize the close ones, and they hope to discover planets that are close enough to be studied in detail. Now, the Vatican Observatory's telescope, the Vatican Advanced Technologies Telescope, is part of a partnership, and you can see the Stewart Observatory, Max Planck Institute for Astronomy in Heidelberg, and the NCU Institute for Astrophysics in Taiwan are all part of this partnership, and they're looking for objects that are close 50 light years of our sun. So in the future, this is formerly WFIRST, the Wide Field Infrared Survey Telescope. The Nancy Grace Roman Space Telescope will search for planets using gravitational microlensing, which I talked about earlier, along with probing the chronology of the universe and looking into the curvature of space-time. So, yikes. That's pretty cool. Some of the things that I've seen that are possibilities, and these are cool, are modular self-assembling swarms, and you can make telescopes that are just ridiculously huge using that. And I actually should have put a slide in that. There was a mission just launched recently that in September is going to be testing swarm-based rendezvous docking and that kind of stuff. So they are looking into this. This is pretty cool. The star shade, a paper thin screen half as big as a football field would origami unfold. It would be positioned tens of thousands of kilometers ahead of the telescope, and it will block out the star's light, much the same way as you block out the sun by holding your thumb up like that. And the star shade's feathered shape is designed to prevent waves of light from flowing around it like water over a rock. And oh my goodness. Oh, hi, bird. I have a parrot that just climbed up my leg. This is Icarus, and she's green. And there we go. Can't be seen. This is Icarus. And you're a little pain in the butt. Hi. You want to join the lecture, do you? The Giant Magellan Telescope is a 25.4 meter ground-based telescope under construction in Chile. It will have a resolving power 10 times that of the Hubble and 4 times that of the James Webb Space Telescope, although it will be unable to image in the same infrared frequencies as space telescopes. The 30-meter telescope is a planned, extremely large telescope. It has been controversial due to its location on Mauna Kea. The TMT would become the largest visible light telescope on Mauna Kea. And this is a concept for the next generation. This guy is going to be looking in the UV and infrared. There are several different concepts designed. One has a 15-meter mirror, and one has an 8-meter mirror. And as you can see, a huge sun shield. And there's also like 3 other types of missions that they're looking into launching in the future. Oh, sorry, bird here. You make giving a presentation kind of difficult, you know? So there are several different ways that you can find exoplanets. There's a whole bunch of citizen science projects out there, and this exoplanet watch has been inviting you to observe transiting exoplanets, and there's a whole bunch of other ones here, like you can find this on the NASA exoplanet archive site. But so they are encouraging the public to look for them yourself. And I have heard of middle school students actually being awarded the title of having found planets. So I wish this stuff existed when I was a kid, because I know what I'd have been doing. So in closing, children of today, like my grandchild here, who looked for the telescope for the first time yesterday, these kids will never know a night sky that's not filled with worlds. And there will never be a shortage of worlds for them to discover in the future. So that is the end of the presentation. So at this point, what I can do is I am going to show you that NASA app, the Eyes on the Solar System. So let's bring up that browser. Look, I need my hands. And I know you like being held like an ice cream cone, but I can't do a lecture with you. I love this bird. Okay, so take that down. Okay, I don't love it when you do that. Okay, so NASA. Eyes on the solar system. Actually, let me just show you this. I'll just NASA eyes. NASA eyes, there we go. And let's go back to Zoom and share that guy. Oh, I've got way too many windows up here. Let's move this over here. All right, so are we seeing the NASA eyes screen there? Okay, this is, if you just type NASA eyes, you'll be taken, hold on a second, I got to get rid of this bird. I love having birds that are so needy. Okay, so if you type NASA eyes, you'll be taken to this site, and these are NASA's interactive sites: Eyes on the Solar System, Interactive Solar System, and you can go to all of the spacecraft and everything. Eyes on Asteroids, you can see the next 5 closest asteroids and see all the asteroids that we've discovered out there, and it's kind of scary. Eyes on the Earth. This is absolutely fantastic, especially if you're doing earth science in a classroom. You can see all sorts of climate data on the Earth, and you can animate, and you can see current climate things like the hurricanes going on. You can see the Earth's cloud cover as it was like yesterday, and it's amazing. But there's Eyes on Exoplanets, so we're going to click on that one. And wait for it. So it comes up with a, did you know? Let's bring it, let's full screen that. So what this is showing you, this is all the exoplanets, and it is interactive, and you can whip around like that. Now that weird splay you're seeing out, that's where Kepler was looking. This thing right here, that's the direction Kepler was originally looking, where it found all those exoplanets. And then as it was moving around, you can see there's it angling out as they were using the sun to orient it. But if they found that many just in that little direction, you can imagine that it's like that in all the directions. So that's just crazy. But again, you can click on any one of these things. But this browse destinations, that's that image I saw. So this goes to, again, you can click on any one of these things. Let's go to WASP 12b because I like that guy. That's the egg-shaped guy. And why isn't that bright? Okay. I don't like that one then. 5 Cancer AB. There we go. Zoom in. There we go. So Hypothetical visualization shows you what the planet looks like. You can see the entire star system and the habitable zone. Zoom in. Again, it works just like if you're familiar with how games work when it comes to scrolling zoom, it works just like that. Information on the star, and you can compare it with the sun. So it's really, really cool. And it does it for all of these things. Different missions that are looking for stuff. There's Tess. It's got a very, very strange camera setup there, those 4 cameras. I'll have to find out why they did that. That's where Kepler looked, that patch there. TRAPPIST, there's a TRAPPIST system, which is that famous one with all the rocky planets. So there's the system. And you can see a bunch of them in habitable zone. But again, this is a red dwarf star. We go to the star, this is a red dwarf. Much fainter than our sun. Much smaller than our sun. And tends to flare a lot, not unhappily. So there are thousands of these, and they update this from the Exoplanet archive. So again, you can click in any one of these things. These are all valid systems, and they'll take you to the different ones. So let's see if I can find Proxima. Proxima Centauri, that's the closest one. Let's see what this looks like. I haven't been here yet in this one. All right, so there's the hypothetical visualization. Now it's showing the system a little different than Space Engine does, and I don't know why. They're only showing B, and I know there's 2 other ones there. So you can also zoom way out and get an idea of how far we've, well, that's the observable universe. Go back, come on. Go back home and zoom out slowly. Okay, I guess that doesn't work. I guess that's eyes on the solar system. Let's go back to the eyes on the solar system. I want to show you some of the different missions. Okay, this is the eyes on the solar system, and they just added the OSIRIS-REx sample return mission. This is, I haven't even looked at this yet. This is probably an animation, and they've added that too. Look at that. Wow, Psyche launch. These are all brand new. Well, this shows you the solar system in real time. You can fast forward or back it up. You can click on anything here and go to it. There's all the stuff around the Earth. So let's go to TESS, the transiting exoplanet survey satellite. So there's TESS. You can see it's orbiting Earth, but kind of far out. And here's all the missions. All planets, asteroids, 147 spacecraft. There are all the missions. You can go to any single one of these. A lot of these have animations, like the landing of the Perseverance on Mars. Actually, well, I want to try this one. Let's go back home. I want to see the OSIRIS-REx because I'm rather excited about this one. This is the asteroid sample that was taken just recently. This thing is going to be returning to Earth, and that is the sample return. I have never seen this. That's the sample return. Turn floodlighting, I can see it better. And it is going to be re-entering the Earth, and they've got lots of asteroid samples there, probably more than they were expecting. The mission itself, the mothership that was holding that, is being repurposed, and it is going to fly by another asteroid, which is really cool. So again, I haven't seen this. Let's fast forward and see what happens when it gets to Earth. The fact that you can do this on your browser or your phone is just amazing. Wow, that looks like it missed. I don't know, it didn't. There it goes. So that is OSIRIS-REx. That is coming home next month, and I am very excited about that. So let's go back here, and I'm going to show you eyes on asteroids. I was blown away when they came out with this. So there they are. Yikes. And you can animate it. Yikes. That is crazy. Let's turn that off. So this asteroid watch here, this is really cool. This gives you this is the next closest flyby, and you can angle around and get an idea of what their orbit is like and get information on the bodies. And actually, I haven't fooled around with filters. They got comets and potentially hazardous asteroids, but just watching all those asteroids, yikes. Our solar system is a mess. There's a bunch of stuff out there. So let's see, what questions do we have? Do we have any questions at all that need answering?
The only one we really had was Roger wants to know, he said this is all really cool science, but why does it matter?
Okay, why does any knowledge matter? We're looking for planets around other, well, the golden goose is looking for another Earth, all right? Because we want to know if there's life out there. Well, I have a feeling we're going to be finding life on either Europa or Enceladus before we find oxygen in the atmosphere of an exoplanet. But the Europa, I'm hoping the Europa Clipper finds the evidence of life, and if it does, what's that mean? Another lander, probably, but who knows? But we thought we knew how solar system was formed until we found an exoplanet that was close to its sun, a gas giant close to its sun that is broiling hot, and we it changed the way we thought about how exoplanets or how planets and planetary systems form. And now we have found thousands of these things, and we know there's what billion. The number is probably inconceivably large for these things, even in our galaxy alone. So what are the chances of life? Well, it happened here. But so why search on it? Well, that again, that's like what good is any knowledge? I mean, it's interesting. Yeah, to me, it's freaking fascinating. But a lot of people like to know where we came from, and this is finding where we came from. That's the best I can do. And I didn't do the search. Brother Guy, he told me a long time ago when I started, I started working on this lecture a long time ago. I told him, I cannot believe how many people there are doing research into exoplanets and stuff like that. And he said, when I was working on my PhD, I knew everyone in the field at that time. He said, there's no way that's possible now. And I've seen some papers with lectures that that long. So there are probably tens of thousands of people doing this, and you can do it too. And the fact that high school students are doing it now just amazes me. I didn't mention it in one of those slides. One of the exoplanets that was found, the professor that found it was actually assisted by a high school student as part of a research project that got high school students doing actual astronomy. So it's filtering its way down into high schools, which is again, I wish I'd had that when I was a kid. So I'm going to close this down and show you Space Engine, because I keep pontificating, stop share, about how wonderful Space Engine is. The Space Engine is an Windows app that it's a universe simulator. They do an amazing. It's made by one guy. I think he finally hired some more people in his team. Are you coming up? Try it again. There we go. When it comes to exoplanets, the cool thing about it is they've posted several times that they have updated their exoplanets from the JPL catalog. So all the exoplanets they have in this, they're the real thing, and it procedurally generates them. Now, what I mean by that is, again, this is the hypothetical visualization. It figures out what the planet would look like based on how close it is, how massive it is, and that kind of thing. And it gives a best guess when it create. Oh, I got to put that over here. Darn it. All right, share, stop share, share. That one. There we go. All right. This is Space Engine. And let's continue. Let's go to Earth first. All right, so this is our Earth, and there's the Berry Center, and you can see the night lights, which is really cool, and you can turn orbits on and stuff like that. But let's go to Proxima. Proxima Centauri b. This is the Proxima Centauri system, which is the closest exoplanet system to us. And we'll travel through the stars. So there it is. That's the visualization of Proxima Centauri b. And I can even land on that planet if I want. But again, this is tidally locked. The dark half is going to be frozen solid on that side, and this end, who knows? Very, very hot. But so this is the other planet in there. That's just crazy. I can't imagine those planets are interfering with each other. And then further out is C, way out there. I need to turn labels on. Oh, come on. There we go. There we go. All right. So, like I said, this application, we live in a sea of stars. This application, one of the things it allows you to do is just accelerate. Now I'm going through. This is through the Milky Way. Remember the old Windows screensaver? Well, yeah, this is kind of like that, but it didn't have dust clouds and nebulae show up. But just take a look at it. I'm going to increase the brightness a bit here because there's just. There we go. Look at all the stars. It's just crazy. There are so many stars around us. Go way into the Milky Way, and yes, I can go right to the black hole in the center of the, yeah, they're all there. So there's a cluster. Slow down. And again, I can click on any one of these stars. Imagine what a night sky on a planet around one of these would look like. So these are all hypothetically generated planets. We don't know about these. There's a lot of stuff there. That's a very hot one, and I'm not actually running now. So let's accelerate time. And you can even see the solar wind pouring off. Ooh, I wanted to show you that. I mentioned the Crab Nebula pulsar. Crab Nebula pulsar right there. Go to zoom. So there it is. Let's dim it back down. And you can see it's spinning very fast and it is messing with gravity. So this is the pulsar at the center of the Crab Nebula. So let's zoom out. That is the supernova remnant. And remember, these are 3D objects, so you can rotate around them. And that is an expanding cloud of guck from a supernova explosion. But you can go anywhere in the universe here. You can go right out of the galaxy. You can see our galaxy edge on if you want. Those are large and small Magellanic clouds here, satellite galaxies. You can go there. Now, this is a question I don't know how to answer this. We see these guys edge on, or we see these guys face on. They're represented like that. And I don't actually know if they're shaped like that. I don't think anybody does. But you can go way out, and now those are galaxies, and you can start seeing the galactic structure. So this is a $30 app, and you can get completely lost in it. And like I say, all the exoplanets that we know about are pretty much relatively accurately portrayed in here. There's WASP. Here's GOTO. Okay, GOTO. Oh. Wait. Look at exoplanet. And if you click on the planet in Space Engine, it'll bring up this info panel over here. So this is a Torrid Jupiter. It was discovered by the transit method in 2007, and it there's its orbital distance, and the period is 2.5 days. Yikes! That thing is cruising around its star. So you can see its tail. It's being blown off in like a comet tail there. So let's expand that a bit. So we've discovered a lot of really weird planets out there, and a lot of really hot ones. I love. You may have heard the star Betelgeuse. That's the one in the arm of Orion. It's probably gone supernova or will be going soon. Betelgeuse. There we go. It displays these huge red giant as very lumpy, which is pretty interesting. And I don't think we've discovered any planets around it, but it does have some hypotheticals, and they're all very hot. Even the moons. Very hot. This is not a happy place. So, like I say, in Space Engine, you can spend the rest of your life traveling around easily. Like I don't know if any of you have watched Dark Crystal, Aughra. I have a feeling this is what Aughra was doing in Dark Crystal. She was playing around, traveling to all different star systems like this. So there is, like I said, the number of exoplanets right now confirmed is 5,000. I was thinking about lunch the other day. What is the total number of exoplanets? Even if I knew, with stars being formed all the time, the last 5 digits would probably be a blur because they're either being created or destroyed so fast over the course of the entire universe. But probably trillions, probably billions in our galaxy alone. And as I said, we're finding the rogue ones. There could be a lot of them. Well, that the rogue planets, they get ejected by gravitational encounters in the formation of the solar system, or whatever. There's several different ways, but if if a star in the early formation, if two planets pass by each other, one can get ejected out, and that is likely what happened. Or they can just form by themselves, but they're all formed. They're all dark, and they're all being found by IR, and more over time. So, any other questions we have here?
Yes, happy to take more questions.
Yeah, we haven't had any other ones pop up, but I've been putting the links in, Bob, that you've been
Oh,
mentioning,
okay, cool.
different
Thank you.
resources. So I encourage everybody who wants to get involved and check out these websites.
Yeah, I've actually the exoplanet hunters stuff. It's super simple. I mean, you're shown pictures, and if it looks like what you think it is, you just tag it, and then the real astronomers will look at it. But there's, as with many astronomical surveys lately, there's so much data, humans can't do it. AI is starting to come in, machine learning and that kind of stuff. The Vatican Observatory Foundation just ran in June their summer school, and the topic was analyzing large astronomical data structures using machine intelligence and AI and that kind of stuff. And the data sets are just getting so big. And Gaia is a mission that is cataloging 1 billion stars around us. Now remember, there's 100 to 400 billion, so it's doing a lot, but it's not doing all of them. And it found a whole bunch of Gaia. When it cataloged stars, it was not only finding their spectra and that kind of stuff, it's finding their relative motion. And then they made a video, and they could determine that these stars probably formed together because they're all moving the same way. And it found a couple hypervelocity stars, which could be from a supernova explosion losing its partner and its partner getting flung off. But they found things whipping through the galaxy. So yeah, Gaia mission is do I think it's found in our solar system. Planet 9. There's been a lot of speculation about Planet 9. I don't know. One of the things that I never see people talk about when it comes to Planet 9 is Hill spheres. Now, what that is every planet has a sphere of influence around it, like a gravitational sphere of influence. The Earth has a gravitational sphere of influence, and after you leave that sphere, the gravity of the sun is more of an effect on you. The moon is inside the Earth's Hill sphere, but its gravity is stronger. So when you pass into the moon sphere of influence, right? Okay, interesting thing. The closer you are to the sun, the smaller your Hill sphere is. So Jupiter's Hill sphere is gigantic. Neptune's is even bigger. So anything way out in the Oort cloud, its Hill sphere would be massive, which is, I believe what they're saying is something that big can affect other things. Do I think we're going to find it? Good heavens. We've searched the entire sky in IR how many times, and we haven't found anything? I'm gonna be skeptical about that. I don't think there's anything out there. There's a lot of bodies for sure. Is one like another Neptune? I don't know. I can't definitively answer that question. They are looking for it though. I mean, there is reason to believe statistically that it could be out there, and people are looking for it.
Don't some people mention the possibility of a rogue planet out there somewhere too?
There's
anything?
always rogue planets. I mean, we found one pretty darn close, but close is like what, 10 light years. But can a Mongo rogue planet come into this? I'm sure it can. I'm pretty sure we're gonna spot it early, but you know, that would be bad actually. a rogue, a Jupiter-sized planet just wandering into the solar system from out system.
It's lonely.
That would do nothing good to the solar system. I could actually simulate that using Universe Sandbox. So by the way, another app, Universe Sandbox, lets you play. I created several of the slides for this presentation using Universe Sandbox. It lets you create solar systems and stuff like that. And many of the star comparisons you saw, I did place the star. I didn't have time running. If I ran time, they'd have all jammed into each other, but and exploded. But so there are a bunch of apps which are really useful. I mentioned Universe Sandbox, Space Engine, this NASA app, a bunch of educational stuff. Great for kids, great for schools. And I would love to see some more schools doing some of this kind of stuff.
Jennifer,
Well,
I'm sorry.
I hope to have some at the branch where I'm working.
Oh, nice.
Really?
I was going to say
Ed
it might be
asked about the recording. It should be in a few weeks. We've just recently discovered that a lot of the recordings did not get up that I thought had been. So that has been fixed, hopefully. That's the YouTube channel for our astronomy programs. It takes a couple of weeks. That's the schedule our marketing department has given us.
So Martin, yeah, thanks. Yeah, the web resources are cool. The one thing I did want to put up here though, is one of the things that I was searching. Let me find it. NASA Exoplanet Archive right here. Putting this in chat. Here's another web resource. This has the latest and greatest on exoplanets, the latest news. You can also search the entire database from here. And when I said I searched to find out how many planets there were about, yeah, I searched this and I put the constraints of, well, it did parsecs, so 15 parsecs at 50 light years. And then I filtered it down from there. But this thing, it shows plots and distributions and the latest discoveries, and you can search on just tons of stuff. So if you're a researcher doing exoplanet research, this site right there, the Exoplanet Archive, awesome. Lots of data there.
I was thinking as we were talking about this and I was looking up some of those links, it might be an interesting presentation to do sometime, Jennifer, to actually just take 4 or 5 of the citizen science websites and even have somebody walk through here on this website. This is what they're looking. I mean, I know they have those videos anyway, but to walk through it as a group where you could ask questions and say, this is what they want you to mark on an exoplanet. And you find that interesting.
You might be able to get the developers of those things to give a talk about it. And I had one of the guys that's an outreach guy for the Worldwide Telescope talk to the WAS, and he showed all the stuff that can do. That's amazing. But
that is a good idea for a program. If you have any other suggestions for program, or you want to be added to the email list that I try to send out, I was late this month. This is my email address, jdye@detroitpubliclibrary.org. If you are in the area, you might try getting to some of the Warren Astronomical Society meetings.
Yeah.
And I got the website here. Let's see whether it transfers cleanly. And I do like getting to the meetings. I have trouble with scheduling it.
I think you missed a letter in it.
Asto.org. Yes, that will not work.
I just put a link for the clubs, the Great Lakes Association of Astronomy Clubs. This is a link to all of the astronomy clubs in the southeastern Michigan area. So you can.
There's the Warren one.
There's a ton of them there. So if you're interested in astronomy, southeastern Michigan is oddly well equipped to serve you.
So if we have no more questions.
Thanks, Bob.
Oh, you're welcome.
Thank you, Bob. Always enjoy your programs.
Oh, and I am going to have to update. I mean, I'm giving this presentation again to the Warren Astronomical Society in October, and I'm going to have to add just a ton of stuff because there is new stuff all the time when it comes to exoplanets.
All right. Well, we do not have a program set for September. It will probably be the 4th Tuesday, but that will depend on who's speaking. I'd like to do a bit of preparation for people to look for the partial eclipse in October. And there's a total eclipse in April that will be total further south of us. So you wouldn't have to drive to Kentucky, which some people did last time.
See it, because there's not going to be another one in the continental U.S. for 20 some odd years. I'm taking my granddaughter to it.
Yes. All right. Well, thank you very much, everyone, for coming, and thank you, Bob. Always fun. Always fun. I know you're still be working on design on this, and I hope to see it at Warren Astronomical.
I'll be adding stuff. Actually, I'll be cutting stuff out because I only have an hour. Actually, I just made an hour during the entire presentation, so it might be good for the WASP. But if I add anything, yikes, I'm going to have to cruise. And by the way, that was, let's see, where is it? How many slides was that? That was 215 slides. I should do videos, I think. because I have a lot of images and stuff. But anyway, I like images. All right.
Okay,
Well,
thank you, everyone.
Goodbye. Good night.
Good night.
Good night, everyone.
Oh, and thank you, Megan, too. I always appreciate your help.
Sure.